as a as a non-technical founder with a background in architecture, Donna had certain superpowers. One of them is the ability to see projects that are coming up in the future in the city ahead of time, and it's something a lot of architects and planners are able to do. That nonetheless, we are not able to see future projects without having special knowledge, special access to the data. And so the idea that there is sort of an invisible city out there, but it's not visible on site. It is sometimes visible through open data portals. But what we're interested to do as In Situ is to think, what can we do to unlock more collaboration and better conversations around urban planning by bringing that information from City Hall out to the street. Augmented reality was the way that we found to do this. So the bigger problems that sort of set us in motion are, first and foremost, the urbanization, more people expected to move to cities by 2050, and then climate change. And so the types of projects that we focus on visualizing are in these two challenge areas, especially multifamily housing for the housing crisis, and climate infrastructure, such as flood mitigation measures, et cetera. And so what we do is basically take the design and planning data and create these elegant AR experiences of buildings and infrastructure that can be viewed at the building, neighborhood, or city level from the street in situ, where your name comes from. So we started as an app, and we're no longer an app, and I'll get into more of that later, just an app-based thing. But the vision was a platform to really lower the friction to visualize and experience projects in AR for internal and external collaboration. We developed different interfaces, a camera view on the street and a web map that shows future projects to offer people flexibility. And some of the folks that we work with, we started by really focusing on developers and trying to help them share projects. And then more recently, we've been trying to work with city governments. And we did a few pilots, which we'll talk about later, in US cities to explore how can we make urban development accessible using AR at a city scale. So from the very beginning, In Situ is focused on not just one-by-one projects, but how can we really bring everything online, this invisible layer of the future, at once, using open data and XR. We also work with AAC companies, and we have a new offering that we're working on as a licensed tool to publish AR projects for studios that already work with 3D. And then the last type of collaboration we do is with technology products through our API to integrate the AR functionality within a larger product or map. So why do we use augmented reality? Basically, it's because it's accessible, intuitive, and empowering. And it's not just AR, but the type of AR we use is smartphone-based augmented reality. So just using your smartphone. This is the most accessible form of augmented reality that exists today. And we think it's important, not just because most people now have access to a smartphone, but for a couple other reasons that might not be so obvious. One of them is that when you're wearing I'm sure you've seen Apple Vision Pro or some of the newer headsets, but one disadvantage of those headsets is you can't share that view with anyone. It's sort of like you're just watching yourself. Whereas if you're on the street looking through your phone, people can look over your shoulder. And so it's not only accessible to the viewer and their smartphone, but also everyone around them. And we found that when we did group events, there's this sort of bystander effect where you start with one person looking through and everyone just wants to see what's going on. And the other thing is, because you're holding the phone in your hand, there's something empowering about that. And Donna felt very strongly early on that there's something different about holding a plan for the future in your hands versus viewing it like on a table in a boardroom or in an unequal situation in one of these meetings where you feel on a lesser status than the people presenting the plan to you. So having it in your own hands, we feel shifts the conversation, shifts the tone of the conversation, and we think unlocks better conversations about the future. So our whole design philosophy is to meet people where they are on the street. And we sort of designed this method of the QR to AR. So using QR codes to go directly to the AR experience with as little friction as possible. It wasn't always frictionless. We in the beginning, I think you remember maybe even 3 or 4 years ago, people didn't just scan QR codes very often. I think a lot of that changed during COVID with menu systems and social distancing. It is more common now. And even if you do scan a QR code, if it leads to an app store download, a lot of people are not willing to go through that. We didn't want people to get stuck at any stage. And so we designed our AR experience to be able to fit inside of an app clip or instant app on Android, sort of a bite-sized thing that can download the AR preview into your phone without having to do the app store. So we developed these hybrid QR codes. It's one QR code that you can scan to go to your platform. And if you scan the code on site, you go to an on-site experience. And if you're not at the site of the building, it leads you to a remote view of the map where you can also see a tabletop sort of AR in your room visualization. And this is sort of what our pipeline looks like. And this is, we're starting to get into the data part. I'm trying to speed along to get there. But we have sort of two sources of data. One is open data from cities, building permits data through open data portals. And the second is models that are provided to us by architects, BIM models. A lot of times architects have BIM models for a project. They're not required to submit those to a city. And so we have to do some experimentation to come up with some incentives to get those models into the public domain for our projects. And then the outputs are, yes, we have a native app. It's still in the App Store, but mainly we're focusing on just the QR codes. And so that's where we're at right now. We also have a web app that has maps of cities, and maybe I can show some later to compare the coverage for different cities. But we started with New York as a proof of concept. We have our on-site signage that is generated when projects are published, either automatically or through our tool. And then we have APIs where you can either generate 3D buildings through Esri City Engine, or you can ingest building permits to publish projects at scale. Some of the capabilities of the actual AR are real-time shadows for special projects. We've done real-time lighting and shadow calculations. We've done some interactive visualizations and sort of slider-based interactivity. So visualizations on top of the built environment. We also have occlusion features. So you can see like for certain projects where it's an adaptive reuse or extension on an existing building, we can occlude or hide the 3D model where appropriate to make it look right in context. It can also cut out people so people can stand in front of the building and take a selfie, for example. We've also done special projects with a little more storytelling. This was like a wildlife overpass outside of LA, where we showed sort of what animals would benefit from the project as well. These are sort of a little more like studio projects that we've taken on over the years. But let's talk about NYC. This is sort of how we got into open data. So what's the problem with open data? We think that it's great that cities spent like a decade in campaigns to liberate our data, make it available to everyone. Unfortunately, it does seem like a lot of that data sort of sits on the shelf. It's not used by public, let alone the city. I overheard a story, I think from Philadelphia, where they had live tracking of their garbage trucks in the city, but the city wasn't using that to optimize routes for the drivers or anything. The only people who were pulling the route data for the garbage trucks were like lawyers trying to sue them or something like that. So there's this issue of like the data is not being used. How do we bring it out, make it more noticeable to people? So we tried to do that in New York by creating the first citywide AR layer of the future to restructure the open data, which is usually in a tabular format, to represent projects in 3D and replace the open data building permits with official 3D model estimation. Actually, this is referring to, so how it works is we get a building permit. The building permit, you can imagine, look pretty different in different cities. And even within like New York City, the text of a building permit might refer to the project very differently. You might have 5 stories, the number 5, you might spell it out 5, and it might describe whether it's commercial or mixed use in different ways. There's not a lot of standardization. So we had to create sort of a role-based system to parse out the spatial attributes of the building permit data and use as a city engine to generate in our pipeline 3D models with kit of parts of not the exact architecture of the buildings, but more or less the envelope that they're going to take up and what they might look like on the street. And then from there, those projects are published on their actual sites around the city. And then if a model that's an official model of the architecture of a building becomes available, we can replace them with those estimated models to get even more accuracy. So we're striving towards 3D planning by default in cities. This is something that I think is our North Star. We're trying to promote that. But as I described, there's a lot of limitations now in the data that don't lend themselves to being spatial. So the big question, I think, for this talk, and we're giving another talk this weekend in a panel at the NYC School of Data, but the question is like, how do we bring open data into space? And as like spatial computing and AI advance, there are going to be people crunching these numbers in ways to create spatial experiences. How do we make that data better, more trustworthy, and in terms of how it's actually used in context, like how can we make it have a better impact and be safer and all kinds of things. So that's the question. This was our first stab at it. 4,000 proposals that we were able to pull from New York. New York City has great building permit data. They publish the permits from the moment they're filed. Instead of a lot of cities publish the building permits after they've been approved. So we're able to get them very early in New York, like years sometimes before anything might appear on the street to let you know that there's some construction that's going to be happening. And so we published this map layer with the 3D buildings. And this was sort of our start towards like our guerrilla campaign. So we took street decals, like sidewalk decals, and put them out to activate several of these sites. And we brought people out to show people in the neighborhood. And lo and behold, there were a lot of locals that had no idea there was something that was going to be built or that a rezoning had been approved, even for their own apartment in one case. So this is, again, sort of our on-site AR and the remote AR that I mentioned earlier. And this is what the signage looks like. And we went through a little bit of some iterations with the signage. So thinking about like, how do we communicate that this is open data from the city that we're visualizing on site, that this is something that's hopefully trustworthy. And in the cases of our pilots that we did with other cities like DC, where we were actually collaborating with the Department of Buildings in Washington, DC, how do we make it official? So like we put the logo of the Department of Buildings on the sign, and then we went from this sort of square version, which says changes are coming to this area, scan to see them. And then we created a new version that I think we might have it
Nick,
later in the
really
presentation.
quick. I had to like change the settings. I don't
Oh,
know if you mean to be sharing your screen for
oh yeah. I
this
don't think
part of
I,
it.
sorry, let me go back
Oh,
through. I
you're
don't think
fine.
I
I just
was.
for some of the visual stuff, I was like, oh no.
Let me go back then. Sorry about that.
Oh no, you're fine. I should have checked before.
So let me start and then illustrate some of the stuff I've been saying. So yeah, we were talking a little bit about the people we work with. This is the experience of the hold in your hand. This is sort of like our pose. Like if we like, this is the what we want to see basically when people are looking up through their phone together. It's like the conversations that we have just get better. It's amazing. And this is the signage that I was talking about, the QR code. Over the years, there's some older versions. We did some partnerships with Snapchat as well. And then these are the data visualization, sort of what that looks like through the camera, the shadows, real-time lighting, etc. Highway project, occlusion, hiding buildings, and sort of how we measure our impact and our theory of change about unlocking better conversations and also reaching beyond the usual suspects who show up to a planning meeting. So we want to reach younger people, people who are busier and don't have time to come to public hearings. This was our New York case study and the map that I was talking about. So this is really our North Star. It's like what if there was a layer of the future built environment for every city that was in 3D by default that you could access both remotely and on site as you're walking around and visualize it. What would it take in terms of open data to make that happen? Right. So we did our case study in New York, had 4,000 buildings with 35 that we activated with this signage. And we, like I was saying earlier, went through several iterations of this signage to figure out what would grab people and convince them that this is worth checking out. The newer versions of these decals have like an arrow pointed tip that directs you sort of which way to look as well. And we had really good results. People spent a lot of time in AR. We got 1,800 views in a few weeks. And for some special projects like the one we did with Snapchat in Midtown Manhattan, we had 100,000 people check out a Snapchat lens for a permit application for a new skyscraper. And the planners said that was like way far and away beyond any level of engagement they had seen before. So that really inspired us. These are some of the cities that we've worked in so far. We did pilot projects in Charleston, DC, and Charleston, South Carolina, and Washington, DC. And we've done smaller projects in Colorado, San Francisco. And then recently we did a series called AR Ready Cities, where we did a series of case studies looking at the most populous US cities and which ones had better open data for building permits that lent itself to better to augmented reality. And so the methodology for that, I think it's not in this presentation, but it might be more interesting from an open data perspective to talk a little bit about that. When we look at building permits from the city to try to find the ones that we can make into AR, we start with like the general data set of all the building permits. Now that includes a lot of projects that maybe like, small alterations, which aren't as interesting to visualize. So that's the first sort of cut we do. And oftentimes like in Chicago, that got us from 2,600 projects to 445 projects that had a building footprint. There are a lot of larger projects that also don't have building footprints. The footprint data is like really important to spatialize, to create visualizations. So the cities that have good footprints are like, you can do so much more with that. And then from the 445 we found with building footprint, 47 permits in Chicago had footprints that had and 3D attributes. Like for us, that means a height, whether it's 5 stories or 45 feet mentioned on the application. And then after doing another round of cleaning, we ended up with 28 projects. So it's for Chicago, that was 2,600. We ended up with 28 that were AR ready. So it's a lot of cities, it's not as good as New York. Like we ended up having to cut a lot of projects out, and it was take collaboration with the city or planners and developers to be able to put more projects on their map. So the recommendations that came out of these reports, for a lot of the cities, the recommendations were pretty similar. One was to publish the city's official building footprint layer and update the job applications on the building permit to reflect the changes. A lot of times the footprints would show the old footprint of the site. And NYC is still the standard for us. I think it still does the best job. We also recommend publishing the permits in their job application stage. So if more cities would make building permits public in the application stage, not after approval, we would be able to have so much more information earlier in the process. And then the third recommendation for Chicago was to publish zoning applications on their open data platform. The zoning review process is the best period for public input to make a difference in the outcome of a project. And In-Situ's AR experience is a great way to engage the public on the zoning process. So when cities aren't open at this stage, it holds us back from being able to do a lot of stuff and generate feedback and insights for the projects. So this was the pilot that we did in Charleston. Illustrates the climate infrastructure side of what we do. They in Charleston they have massive challenge with flooding in their downtown, and there is a big project to do a perimeter protection sort of seawall. Now, when I heard seawall, I hadn't been to Charleston yet. I imagined a giant wall. But when we actually modeled one of the stages of the project and put it on site, it was actually a lot less imposing than I thought. And I kind of couldn't believe that there was a lot of controversy about it. But that was one of the things that was so interesting for me. Really challenged my assumptions about the project. And I think that's one of our goals is to like clear away a lot of the assumptions people have. And then we showed some other projects in town. That's the mayor using it. And there was a new hotel on King Street in downtown that we showed. Now, for Washington, D.C., this is an example of a developer architect actually of a new project that was a public RFP from the city. So city land that they're competing for the rights to redevelop this site. It was actually the new home of the NAACP, and it also included housing, really high profile project. So they really wanted a lot of public engagement for the project. And in fact, the architects, before they met us, had to go out with clipboards and every day try to get enough feedback to be able to put their proposal together. And they said that if they had a tool like this to be able to visualize it on site and get passive feedback coming in, it would have made their lives a lot easier. So we thought that project was pretty cool. One of the things I've been doing with our community work in New York is to have events like this where we do walks in the future and visit 4 or 5 projects in one neighborhood. And I think this is kind of my ideal use of our tech right now. Like get a group together, go out, walk through the streets, and you come away like with a very different image of what's happening in the area and much better knowledge that you can then share with other people. This was Syracuse Open Data Day. I don't know if anyone was there. This might be a bit of a repeat for anyone that was there, but we brought a demo up for the site. This is what the new decal looked like. I mentioned with the arrow tip on the front. So we're thinking a lot about signage. And this Sunday in Brooklyn, we're hosting a walking tour with Helpful Places, which is a nonprofit that's trying to do a sort of communication standard for communicating urban technology in the built environment. And so they're going to walk around and show us like how they communicate where sensors are in the street and sort of different urban hardware. And then we're showing how we communicate the digital layer on the street as well. So why are we doing this? Basically, there is a lot of momentum now. There's a lot of legislature going through cities in the US about making zoning reforms happen. We're going to Arizona on Thursday, and I just heard that the governor vetoed a big bill. It was a bipartisan bill to reform single family zoning and to make it more possible to build multifamily things. That's been a very similar story in a lot of places around the country, like Austin and Minneapolis. I think legalized fourplexes or got rid of single family zoning. There's a lot of variations on a theme happening. So these big conversations are happening. There's a sense of possibility, but also major challenges with getting buy-in. And so I think we need something like this to help improve these difficult conversations. In terms of the technology, AR is kind of not, it's coming for cities. I think right now we're at the Apple Vision Pro is just launched, right? And there's a lot of AR tech that's really powerful at the room scale, but it's starting to creep out into the urban landscape as the technology and the ability to overlay things geospatially. So we use Google's geospatial API, which basically lets us anchor things on a Latin long point and match up with Street View data to match your phone's view to where the 3D object should be. And that technology is advancing crazy rate right now. And so I'm really excited to see what's possible. But I think everyone must remember like the Pokemon Go, I think was like the first big scare of like, oh, wow, okay, this is what can happen when we have digital layers overlaying everything. And so as that tidal wave continues to approach, I think one of the things we're thinking about is, okay, how do we make the official layer or the open data give it a place in all of that noise that's going to be coming overlaying our built environments, and how do we communicate that in a trustworthy, noticeable, engaging way to people so that the open data does not continue to sit on the shelf in the era of spatial computing and AI. So yeah, and then not to mention the bigger challenges of housing and climate as well, and some tough conversations that we have to have in the future. So everyone must know the story of Jane and Robert, and this has been the story of urban planning in our cities for so long, like these giant fights about projects, big sort of black and white narratives. And our dream is that someday, I think, tools like In Situ could be used for collaborative decision making and less for just, communicating what has already been decided with limited input. So yeah, I think this is where I'll leave it. If there's any questions about the data itself, I'll do my best to answer. I'm not, our data engineer could not be here, but I'm happy to take a stab at it. And I'm really curious to hear, I guess, where everyone's coming from and if any projects are in your mind. I've heard in Syracuse that they're planning to like get rid of a giant highway. And I know that's a big conversation, right? So yeah, thank you for your time. And once again, I apologize for the last minute substitution with Donna and for not being 100% prepared, but it was really great. Thank you for the opportunity.
Thanks, Nick. I know I have a couple of questions, but Faye and Jerry, if you have anything that you guys want to ask, feel free.
Yeah, I have a couple of questions too. I guess my first question is, what's the data format of the building footprint?
Right. So it's tabular data, like text. I mean, I think we can see on, let's see, on our map, I could show you. I need to be able to get like an actual building permit to show, but if you can imagine just like a paragraph description of a project being like a 5-story project that is mixed use with retail on the ground floor, and we're parsing the paragraph from the building permit. Sometimes it would be spreadsheet or different formats, but nonetheless, it's like not visual data, so tabular data. And then we have a role-based schema that our data engineer developed for each, which has to be unique to each city, to try to pull the spatial attributes out of that. So I think there's room for improvement here. We're sort of trying to promote. We actually developed at one point like our own standard, our own data specification for how this might work. But we think that if cities collected data in a spatial way from the beginning in their building permits, that would allow a lot more 3D calculations and be compatible with BIM and other things that are common in planning now. Sorry, I hope that helps. I don't know exactly what the format is for New York.
It's kind of hard to imagine how you pulled the basically made a polygon or a shape out of a paragraph of descriptions. Would you think that's 100% accurate, or is just estimated?
It's more accurate for the height, and then yeah, the accuracy of the footprint depends on the accuracy of their data, but it's basically extruded footprints, and then the text of how many floors will determine how the buildings are constructed. I think if you look up let's see, find a example of our generated buildings, but they're essentially like extruded footprints that are a little more detailed in the architecture, because we have like the windows and floors and stuff. It's sort of like a kit of parts that is sort of pasted together. So like you can copy the windows up 5 floors, for example. And the New York ones look different from the Charleston ones. So we sort of created like a different asset pack for Charleston and New York to sort of match the local style, but it's not the actual architecture. So that was a design choice that you had to think about in like terms of like how do you make people aware that this is not what the actual building's going to look like. That's why the auto-generated models in our system are grayscale. And there's also a disclaimer, I think, that says something like this has been generated based on publicly available information, something like that. So that was another consideration.
Okay. So does it? So for the auto-generated models, does it each time a user scan a QR code, it will generate in real time?
So the publishing process in the pipeline happens like however often we would decide to do it, but they built it so it's not at the point of scanning, but it's at the point that we publish the layer on the map. And so at this point, the one that we made for New York is about a year old. And so there are a lot of projects that are probably complete. And so that's another question we're figuring out is like, how often do we do a refresh of them? And I'm not sure exactly how long it takes to do them, but it's not very long. It's a matter of a few hours. And once we realized that it only took that long, we started to try to do it for other cities. And so we did, I think, San Francisco in like an hour. We generated like 100 projects across San Francisco. And that obviously bears some quality assurance. And we had to check in each city to see if it was coming out and the footprints were looking accurate. But yeah, it's if it, the quality of the data is the main, not surprising, like the main limiter, and the actual ability to generate projects is pretty quick. I think if we had good data, we could do a lot.
Yeah, this is really cool. Thank you.
Thanks. Our maps is, I think if you go to Institute, let me see, app.institute.us/map/NYC. Let's see, it's not working for me. /NYC. I can put it in the chat. You should be able to see our New York. There's New York. Yeah. Our reports, let's see, we put them on LinkedIn, but gotta find a way to publish our study on. We're trying to do 10 cities. We're at like 6 cities right now. So we did Chicago, Austin, Seattle, Los Angeles, and there's another one. I think Detroit coming next week. I don't know if anyone has any guess which ones are the best, but I think it's not surprising. New York was the top. Chicago, Boston, and Los Angeles, and Seattle, I think, were like the top 5. And that for me wasn't so surprising. I recall like Chicago had a very strong open data movement, and I think it does correlate, like the strength of the open data communities in the cities really resulted in stronger data there.
So you mentioned that Syracuse has a big project like the highway taken down. Do you think there's some application in that you visualize something being taken down instead of being built?
Sorry, I mean, yeah, that's a good question. So the models do overlay the existing architecture, so I think it's very possible that we could do that. One of the things we've been experimenting with more recently is being able to convey street redesigns, so bike lanes, and we're doing a project in Columbus, Ohio. That's like a bus rapid transit corridor. So it's a multi-sided project where we're showing new bus rapid transit stations and new dedicated bus lanes that are going in, and like micro mobility hubs, etc. And so we'll be overlaying that infrastructure on top of the existing roadway. And it's a new thing for us. We'll see how it goes, but so far it's been looking really cool. We also had a early adopter for our new In-Situ Pro tool that is working on. His name is Kieran, and he has a tool called 3D Street, which it works with Street Mixes, this like 2D street redesign tool. And so you can generate sort of your own proposals for 3D street redesigns, like bike lanes and buses, and sort of move the models around in an easy to publish way. And then we experimented with taking those 3D models and then putting them in AR on the street to cover like the roadway. So that's another area I'm interested in, as well as parks and placemaking. I think would be very interesting to be able to do stuff like that. And if anyone's interested to give it a try, we'll be launching In-Situ Pro pretty soon with like a trial program, and it's pretty much like drag and drop. We take a 3D model in GeoView format, and we have a sample library so that you can try publishing it in your area. So the main limitation at this point is the data for positioning the models comes from like Google Street View. So it works really well in pretty much any city downtown area where you can align to the street. But very interested to get people to start trying it out when it comes out. We're looking probably like April 1st, and that'll be up on our site.
Nick, there was one thing, and I might be like misremembering from the presentation from the open data day at the Syracuse library, but for the models that you have, do they account for like shade from the building? I can't remember.
Yeah, there is. So the features sort of depend on the project, which features we use, but one of the features is real-time lighting that takes into account the time of day you're looking at the model from. And so, yeah, that's definitely something we've done before. I'm trying to find like some more examples from our Instagram page that would be good to look at.
I just remember there was, and this was like years ago, and I can't even remember if anything came out about it. I remember the Brooklyn Botanical Garden was having like, I don't know, there was some development that they were going to put across.
And it was going to shade it. Yeah,
so
I remember.
They were freaking out. They were like, but our plants. Like,
right. Normally I would be like, I don't, think shade should hold back a project. But in that instance, it's like, that's the Brooklyn Botanical Garden, probably something worth discussing, right? This is another example of our auto-generated architecture. You can see how it's sort of like, it's not just an extruded shape. We have a modeler that designed this style for Charleston, but it is sort of limited to the data that we have in terms of like, this was a 4-story building with commercial on the first floor. And so it looks like this. And that's sort of the output. Then let's see, is there anything? This is a custom building that shows some of the lighting. This was a project in Charleston where the architect provided us the actual model. And I think later in this reel, it shows what the occlusion looks like so that you can see the person is cut out in front of the 3D model. And then we just got back from Austin, and this was a project where we visualized it's going to be the tallest tower in Texas when it's done, called the Waterline. And so this is like in real time, how fast you get in from scanning the QR code to loading the 3D model. And so in this case, it was like about 20 stories underway. And so you can see sort of like where it will top out when it's done. Yeah, it was a pretty quick demo, but I thought that was pretty fun. Yeah, so that's pretty much it. I'm really excited to invite everyone to check out In-Situ Pro when it comes out. And there is, let's see, any other events we're doing. Pretty much just this weekend, there's the School of Data in New York City at where we're going to be having a panel. And then on Sunday, there is a walking tour that I mentioned earlier. And I was going to find the link to that just in case anyone is in the area. This is the link to that walking tour with helpful places. But got about 10 more minutes, I guess, if anyone has any questions.
Baker, Jerry, do you guys have any other questions for Nick?
I don't have any more questions.
Cool. Well, thanks so much. It was really great. Hope have a great open data week. It's really exciting what's been happening up there and like how much more community there is. I really hope I can get back up there pretty soon. I go up to Binghamton sometimes because my girlfriend lives there. So I'm looking forward to be checking out Syracuse again soon.
Well, thanks, Nick. We really appreciate it and awesome talk. And thank you
Thank you.
again.
Thanks, Nick.
Yeah, take care, everybody.
Bye,
Thank you.
everyone.
Bye.
Bye.